Dear children, welcome to the third module of our chapter, Some Natural Phenomena. I hope you all are fine and doing well. In this module, we are going to learn about lightning. During a thunderstorm, lightning and thunder occur together. However, we see a flash of lightning first and hear the thunder afterwards. This is because light travels faster than sound. Till 1752, nobody really knew about the cause of lightning. Benjamin Franklin was the first scientist with a brilliant experiment proved that it was caused by static electric charges in the clouds. He flew a silk kite into the clouds during a thunderstorm with a metal key tied to the thread of the kite. He got an electric shock when he touched the metal key. This happened because the charge in the clouds flowed down the wet string to the metal key. When the metal key was touched, heavy charge flowed through Franklin's body to the earth, giving him an electric shock. Thus, he proved that clouds build up charge during a storm. Now, we will go to the details of lightning process. Lightning is caused by the accumulation of static electric charges in the clouds. It is an electric discharge between the clouds and the earth or between different clouds. A very large amount of electric current is generated during a lightning strike. The air in the path of lightning heats up enormously. Its temperature reaches about 30,000 degrees Celsius momentarily, even hotter than the surface of the sun. This causes the flash of lightning that we see. Children, you learned about the development of a thunderstorm in class 7. During this process, the air current moves upward while the water droplets move downward. These vigorous movements cause separation of charges. When condensation takes place and clouds are formed, these clouds have a huge amount of static electric charges. It has been found that the positive charges accumulate near the upper part of the clouds and negative charges near the lower part of the clouds. But it is not known exactly why this happens. However, some experiments have suggested that charges develop in water droplets present inside the clouds. It is seen that lighter droplets acquire positive charge and being lighter move to the upper regions of the clouds. Bigger droplets acquire negative charge and being heavier move to the lower regions of the clouds. There is an accumulation of positive charges near the ground also. Children, you know that air is an insulator of electricity, or it is considered as a bad conductor of electricity. But when the magnitude of the accumulated electric charges inside the clouds becomes very large, the air contacts and the positive and negative charges meet, producing streaks of bright light and sound. We see the streaks as lightning and hear the sound as thunder. This process is called an electric discharge. The enormous amount of heat produced makes the air expand very suddenly. This causes a wave of vibrations which is called a shock wave, and that is the cause of thunder that we hear. Lightning can occur between a cloud and the ground, or between two clouds, or even between two portions of the same cloud. Thus, we see that lightning is accompanied by large amount of electric current and very high temperatures, both of which are very dangerous. We must therefore learn to protect ourselves during a thunderstorm.
The image is unmistakable. Lightning is one of the most incredible natural phenomenons, and one that scientists are still learning about. It's a common occurrence during summer when the heat of the day is broken by strokes of lightning. Worldwide, it's estimated lightning occurs 50 to 100 times a second. The greatest concentrations of lightning strikes are in Central Africa, the Himalayas, and South America. Lightning is often seen flashing between storm clouds in the earth. The bursts of light are pure electricity. Scientists don't fully agree on what actually causes the electrical charge to be dispersed, but it is generally thought that lightning often occurs within the downdrafts and updrafts of thunderstorms. Lighter particles moving toward the top of clouds become positively charged, while heavier particles heading toward the bottom become negatively charged. When the positive and negative charges grow large enough, lightning is released between these regions. Most of the lightning takes place within the cloud, but some strikes the earth in bold flashes. In these cases, the charge escapes the cloud, making a branching path that reaches for the ground. The energy of the lightning strike contains hundreds of millions of volts and lasts only a fraction of a second. What seems to be a single flash is actually a series of return strokes of electrical energy reaching back up into the clouds. The path reaches temperatures of around 50,000 degrees Fahrenheit. This extreme heat creates the booming thunderclap as excessive pressure within the lightning path expands at supersonic rates on return strokes. In the U.S., lightning occurs most often in Florida. Its hot, moist climate is perfect for creating thunderclouds, which produce lightning. But lightning is a deadly natural phenomenon, taking nearly 100 lives a year on average in the U.S., more than hurricanes or tornadoes. During electrical storms, experts warn that people should seek shelter inside a building or hard-topped automobiles, and if caught in the open, avoid high ground and isolated trees. Lightning is a powerful force of nature and one to be cautious of.
So children, we have seen that lightning is an electric discharge. The spark from the electric lighter used to ignite cooking gas in the kitchen is another example of electric discharge through the air. I think you may have seen this. Children, we have seen that lightning occurs due to the accumulation of static electric charges inside the clouds. Clouds can charge tall buildings and trees by induction. The buildings and trees thus occur the opposite charge. If the buildup of charge is very high, heavy flow of electric charge can occur between the clouds and the tree or the building. This can be very dangerous and can result in the building or the tree catching fire because of the huge amount of energy released. Thus, we use a lightning conductor to protect it. So, lightning conductor is a device used to protect buildings from the effect of lightning. Children, we have seen that lightning occurs due to the accumulation of static electric charges inside the clouds. Clouds can charge tall buildings and trees by induction. The buildings and trees thus occur the opposite charge. If the buildup of charge is very high, heavy flow of electric charge can occur between the clouds and the tree or the building. This can be very dangerous and can result in the building or the tree catching fire because of the huge amount of energy released. Thus, we use a lightning conductor to protect it. So, lightning conductor is a device used to protect buildings from the effect of lightning.
Lightning conductor. Did you know that lightning is a gigantic electric discharge occurring between two charged clouds or between a cloud and any object on the surface of the earth? It was the American scientist Benjamin Franklin who showed that static electricity formed due to friction between the droplets of water and particles in rain clouds results in lightning. A lightning discharge passing through a building can cause serious damage. However, buildings can be protected from such damage if a lightning conductor is installed in the building. A lightning conductor is a device which is used to save tall buildings from lightning. A lightning conductor is a flat, thick strip of copper with several sharp spikes projecting from the highest point of the building. The lower end of the lightning conductor is connected to the copper plate buried deep into the earth to provide good earthing. When a negatively charged cloud passes over the building, it induces positive charge on the spikes and negative charge on the copper plate. The discharging action of pointed ends sets up an electric wind of positive ions, which neutralizes the negative charge on the cloud. This decreases the potential of the cloud and the negative charge on the copper plate is neutralized in the earth. If lightning strikes the conductor, then an electric discharge passes down the copper plate into the earth and thus prevents the high current from passing through the building.
Children, a lightning strike is very dangerous. It can destroy an entire building or a tree on which it strikes. It is advisable to take shelter in a safe place when you hear thunder and not to remain in an open place. A building, especially one with lightning conductor, is safe. Only closed vehicles are safe from lightning. Open vehicles such as scooters, motorbikes, open cars, tractors, trailers carrying machinery are not safe. Get out of these vehicles immediately. Open fields, tall trees, shelters in parks, bridges, etc. do not protect us from lightning. Carrying an umbrella also invites lightning. It is better to take shelter under a small tree. It is better to squat low on the ground. That is, place your hands on your knees with your head between the hands. This position will make you the smallest target to be struck. That is, in this way, minimum part of your body is exposed to lightning strike. Do not lie flat on the ground because you expose more surface area to lightning. Now we will discuss the precautions to be taken inside a house. Lightning can strike the exposed metal pipes, telephone wires, TV antennas and electric wires. Avoid contact with these during lightning storm. Use only mobile phone and please make sure that you are contacting the person who also has a mobile phone. Do not call through a landline, as in doing so, you may endanger his life. It is better to unplug appliances like computers, TVs, landline telephone, etc. Do not take bath as you can receive lightning shock through metallic water pipes. Watch the next video that will also give you an understanding about the precautions to be taken in a lightning storm.
According to the National Weather Service, lightning strikes somewhere on the surface of the Earth 100 million times each day. Each strike of lightning contains about 1 billion volts of electricity. That's enough energy to light a 100-watt bulb for 3 months. With all that power, it's amazing many researchers call lightning the most underrated of all weather hazards. Lightning is the second leading cause of storm deaths in the United States. In addition, lightning causes millions of dollars in property damage in this country alone. But the good news is most personal injury and property damage caused by lightning can be prevented. At the first sign of lightning or thunder, seek shelter. Good shelters are substantial buildings or fully enclosed vehicles, like a car, truck, or van. Be sure to keep the windows completely shut. Unsafe places are open spaces, like sports fields and golf courses, high ground, or under trees. Be sure to stay away from metal objects, including small machinery, electric wires or equipment, and metal fences. If you are indoors, avoid water, stay away from windows and doors. Do not use the telephone, turn off, unplug, and stay away from appliances, computers, power tools, and television sets. Lightning can strike electric and phone lines, causing shocks or surges to inside equipment. Consider installing surge protective devices, SPD, on electrical equipment. These systems can provide significant protection for electronic and electrical appliances. Be sure to keep them installed at all times. Also, consider adding a lightning protection system. These systems include lightning rods and air terminals. They provide a direct path for lightning to follow to the ground rather than through the house and its wiring. However, a lightning protection system will not protect a home from fire or electrical damage from lightning entering through the telephone, cable, or electrical lines. Whole house surge protection devices are needed for this type of lightning strike. A whole house surge protection system can be installed by the electric meter or the main electrical panel to help protect the appliances and electrical equipment in your home. Contact your local electric company for installation information, or a qualified electrician or contractor for installation. For more information about protecting your home from disaster, visit www.flash.org today.
Children, this is the point to be written in your notebook from today's module. Lightning conductor is a device used to protect buildings from the effect of lightning. So I hope today's portions are clear to you. Thank you. Have a nice day.